Hi, everybody. My name is Anshul, and in this video, I'm going to demonstrate how we can include categorical data into a regression model by using dummy variables. And I'm going to show some data in Excel and then give a demonstration in R about how we can run that regression model. So we'll get started by looking at this data here in Excel. And let's say we're interested in the research question, what is the relationship between blood pressure and gender? And so what we did is we went out and surveyed, say, 16 patients who were in the hospital, and we collected data on their blood pressure, age, gender, and marital status. And we put it all into this spreadsheet. So for example, the person here in row 2 is the first person we collected data on. They have a blood pressure of 194. That's their systolic blood pressure. They have an age of 67 years. Their gender identity is female, and they are married. So now we want to run a regression analysis that has blood pressure as the dependent variable and has age, gender, and marital status as the independent variables. But you'll notice that the gender and marital status variables are both qualitative. They're qualitative categorical variables, which means that we cannot just give them to the computer in this exact form and be able to make a regression model, because the computer can only understand numbers. The computer cannot understand the levels of this gender variable, which are female, non-binary, and male. And it also won't be able to understand the levels of the marital status variable, which are married and single. So we need to modify this data somehow before we can give it to the computer. So let's start to make that modification. I'm going to modify the gender variable starting here in column E. And so I'm going to make variables called male, female, and other. And here I'm going to mark down whether somebody is male or not in column E. So this person is a female, so they're not a male. This person is non-binary, they're not a male. This person's female, they're not a male. This person identifies as male, so we would write yes, and then we would keep going like this down the line. Now let's do it for the female column. Is this person a female? Yes. This person in row 2 is a female. This person in row 3 is non-binary, so they're not a female. So in column F, we put no. This person is a female, we put yes. This person is a male, so we put no in the female column. Now we move over to the other column. We're going to correct that to non-binary. There we go. And we're going to say, so the first person is female, so they're not non-binary. This person is non-binary, we write a yes. The next person is not non-binary, we write no. Same for this person. Okay, so we could keep going like this. And now what we've done is we've created what I'll call a yes-no variable here for male, female, and non-binary individuals in our data set of 16 people. So this gets us closer to something that the computer can understand, but it's still not numeric data, which is what the computer really wants before it can run regression models for us. So we're going to rewrite these variables one more time. So let me demonstrate that. Here we go. So we're going to convert no and yes to 0 and 1. So now a 0 means no, and a 1 means yes. So this column H here is meant to be equivalent to this column E here. And so I wrote 3 zeros, just like here we have 3 no's. And then I wrote a 1 here, meaning yes. So 0 means no, and 1 means yes. All right, let's keep going. So we have a female in row 2, not in row 3. In row 4, we again have a female. And then no, we don't have a female in row 5. Now over to non-binary. No, yes, no, no. So I'm just mirroring column G. Okay, now I'm going to delete these columns. We don't need them anymore. The next thing we're going to do is we're going to look at how do these numbers, these zeros and ones, allow the computer to figure out somebody's gender. So the idea here is that we're going to ignore column C and we're going to check to ourselves, can we just use columns E, F, and G to figure out somebody's gender? So don't look right here at C2. Imagine you couldn't see that. And now the person in row 2, can we figure out their gender? Okay, so we have a 0 here. So we know they're not male. We have a 1 here. And that tells us that they are female. So that's the answer to our question. The person in row 2 is a female. And then, of course, we have a 0 here in the non-binary column. But we had already figured it out by that point. Okay, let's try for row number 3. Let's figure out what is the person's gender in row number 3. Okay, is that person a male? No, we have a 0 here. Is that person a female? No, we have a 0 here. Are they non-binary? Yes, we have a 1 here. And let's double check that. Oh, look, that person is non-binary. So that worked out. Perfect. Okay, the next thing we need to do is fill in the rest of the sheet. So I'll do that and show you the result. All right, and there it is. So now we have a complete data set with the gender variable, the original gender variable in column C, now broken down into these 0 and 1 variables, 3 separate variables, which are called dummy variables. And they're also called binary variables or also yes/no variables. So you can call them any of those things. You can think of them as just being a no or a yes. A 0 is a no, a 1 is a yes. And all of those 3 terms, dummy variable, binary variable, and yes/no variable, are all commonly used terms for this type of variable that you see in columns E, F, and G. Okay, so now we'll talk about one other quick detail before we move on to running a regression analysis on this data in R. And that additional detail is, you might remember that when we were trying to figure out the gender of the person in the first row of data, meaning row number 2 of the spreadsheet, right here, we went through male, female. We were able to figure it out as soon as we got to the second column, meaning we looked at male, we looked at female. We didn't need to look at the third column. And then again here, if we go down to row number 3, the second person, as soon as we know this is a 0 and we know this is a 0, then we know that the person is non-binary. We didn't actually need to look at that third column. And so what we're going to do is we're going to eliminate one of the 3 columns. In this case, we'll eliminate the male column. And now male is gone, but we can still identify all 3 genders very easily. We know the first person is a female because we have this here. We know the next person is a non-binary person because we have this number 1 here. And then let's skip down to row number 5, meaning the 4th person in our data. We know this person is a male because this is a 0 and this is a 0. What else could they be? The other category that we left out, which is a male. So when we give this data to the computer, it's not going to accept a column of data like this, like gender. It's going to need only numeric variables like blood pressure, age, and now female and non-binary are going to be acceptable to the computer to include. And we're going to demonstrate that in a moment. So what I've done here is I've taken us back to our original data set because I also want to demonstrate how we could create the dummy variables rapidly for ourselves in R. So what we're going to do next is load this data set into R and then continue our analysis over there. All right, and here we are. We're in RStudio, and this is an R Markdown document where I can put my plain text here, as well as any R code that I want in these gray chunks. And so we're going to use this to organize our analysis in the rest of this video. So as I said before, we're trying to find out the answer to this question in line 23. I'm just going to load up some of these packages, and then we're going to load in the data. So here we go. I ran line 45. Let's inspect the data, which is just called D. And here it is. So we've got 16 rows, that's 16 patients, and we have these 4 variables for our 16 patients. The next thing we're going to do is we're going to use the fastDummies package to create the dummy variables that I just demonstrated us making in Excel. And so we loaded up the fastDummies package up here in lines 36 and 37. Let's run line 55 now. And let's look at our data again. It's still open here. And there we are. We've got our 3 dummy variables for female, male, non-binary. And we also have dummy variables for marital status, because that's another qualitative variable from our original data right here, which the computer won't be able to understand unless we put it into dummy variables. All right, so let's go back to our code. And now we are ready to run the regression model. So let me do that. So we've got the code for that right here. We're just going to run an OLS linear regression using the LM function. We're going to store it as a regression object called reg. And then I've got my dependent variable here, blood pressure. I've decided to include gender female and gender non-binary and leave out male, because as I just told you, the computer does not need to know all 3 columns. And then we're going to include the age variable, which is already a continuous numeric variable. And then we're going to include marital status single. And then we're going to look at a summary of the output. Actually, you can see it's already there from when I ran it before. I'll just run it again, and we get the same thing here. So that's our result, and we're going to spend some time in a minute or two looking at these results more carefully and understanding how to interpret them. But first, I just want to point out a couple of things. So let's try this. Let's say we had included the male variable as well. So I'm going to type gender underscore male. Whoops. We'll get that out of the way. And we will also accidentally include marital status underscore married. Save that. Click the button. Look at this. The computer knew that we made a mistake. This row is blank here for male, and this row is blank here for married. So the way a regression model works is that you have to leave one of the categories out. And the computer will just throw one away for you, basically, if you accidentally do include more than you should. The computer will figure it out. In the past, in older versions of statistical analysis softwares, maybe it would cause an error instead of giving you a result. Okay, so I have restored it now to how it was originally, so that we just have n-1, we call it, meaning the number of levels in a variable minus 1. So there were 3 levels of the gender variable and 2 levels of the marital status variable, right? There was either single or married. And so we're including just one of those. 2 minus 1 leaves 1. For gender, there was female, non-binary, and male. So 3 possible levels, and minus 1 of that is 2. So we include 2 here in the regression model. Okay, let's start to look at our result. So our intercept is 210. Our female coefficient estimate is negative 10.24. Our gender non-binary is negative 4.47. Age is negative 0.12. Marital status single is 0.88. It looks like I did not run it again after modifying it, but those numbers will be the same. And now let's pretend I want to include male. So I'm going to put in male, leave out female. Okay, so previously this negative 10.24 was comparing females versus the reference category of male. Now let me run this. Now it flipped from negative 10.24 to positive 10.24. So the actual regression model that's being run is identical, no matter which variables I choose to include or leave out. And we can see that the intercept is the same, the age estimate is the same, and the marital status single estimate is the same. And of course, we could have changed this. We could change the single here to married, and then this would switch as well to a negative 0.88 instead of a positive 0.88. And we'll talk more in a moment about how we interpret those. And then I also want to point out that the R squared is the same in all the different versions of the model, because the computer has the same information and data. Using just two of the columns for gender, it knows the gender in all three scenarios for each person. It can figure out the gender of the person who's left out, as we demonstrated earlier in the Excel version of the data. Great. So before we get to a more in-depth look at the interpretation, I want to cover one other topic related to the actual coding and writing of this regression model LM command. So in R, what if we did just type the original gender variable, right? So what I mean by that is, let's go back to our data. What if we did not have this and we did not have this? We didn't have any of these dummy variables. Let's say they were not there. And let's say that we just typed gender just to see what would happen, even though it contains words that the computer cannot understand. What does it do? Well, modern statistical platforms will still run the model for you, and it will automatically make dummy variable columns the way we just demonstrated. It'll do that behind the scenes. And you can see here we have the exact same regression result. Same R squared, same estimates, everything will be the same. So this is a quick way to do it. And now, as a more experienced statistician, when I run my own analyses, this is how I do it. But if you're one of my students and you're watching this, in my class, we like you to do it the old-fashioned way, which is to create these separate columns and these separate variables with dummy variables, so that you actually have some practice and some intuition behind what is the computer doing for us and how do we interpret the results. So that's just something to keep in mind. You might have in the past run it this way. And of course, we did the same for marital status. And it just chose for us to keep male and non-binary and choose female to be the reference category. And for marital status, it chose to keep single in and leave out the column for married, which is the reference category in that case. But again, we're going to do it this way, where we control what the reference category is ourselves, and we also get to think a bit about what's going on in the data for us to get this regression result. Okay, now let's turn to the interpretation of these results, because we have this nice table, but what does it all mean? So what we're going to do is we're going to start off by writing the equation for this regression result. And so our dependent variable was blood pressure. And I'm going to put these $ signs in to write an equation, totally optional. So I'm going to call it blood pressure equals, and I'll just go down the line, 200.14 is my intercept, plus 10.24 times male, plus 5.77 times non-binary, minus 0.12 times age, plus 0.88 times single. So we often leave out the word gender. Here I just wrote male. I didn't write gender male. Here I didn't write marital status single. I just wrote single. We often leave it out when we're talking about the equation, but either way is totally fine. And so you see it showed up nicely when I sandwiched it in the dollar signs. Okay. And so now let's talk about how we interpret these coefficients. So let's first start with one that might be more familiar to you, and that would be age. So in this data, peculiarly enough, when we have for every 1 unit increase in age, blood pressure is predicted to increase. Oh, let's fix that. Decrease by 0.12 units. And that's, of course, on average, controlling for all other independent variables. And that's in our sample only. We'll just talk about the sample interpretation for now. Good. So that's more intuitive to us if we're used to just dealing with continuous numeric independent variables like age. Great. Now let's move to one of the gender variables. And in the latest version of the regression here that you see, it looks like females have been left out. So females are the reference category. So we'll just go with that for our interpretations. But remember, it doesn't matter exactly how you run it. Okay, so what I'm going to do is I'm going to start by writing this exactly the same way that I wrote it for age. In our sample, for every 1 unit increase in male, blood pressure is predicted to increase by 10.24 units, right? So if we did not know that this male variable here, was a special qualitative dummy variable, then we would just write our interpretation the way I did here in line 76. So what does this actually mean, though? What does a 1 unit increase in male represent? Okay, let's go back to our data and try to figure that out. Ooh, and let me save my work here, very important. Okay, over to the data set. Let's check this out. A transition from being 0 on male to 1 on male. What does it mean? It means that someone was not male before, right? This person is female in this example. Let's imagine they changed into this person. Now they're male, they're not female. So a change in male from 0 to 1 means a transition from female to male, because female is the reference category. So it's a transition from the reference category to whichever variable we're talking about, whichever dummy variable we're talking about. So let's write that down. And there it is. So we rewrite the interpretation for the male variable, and we'll say transitioning from the reference category, which is female. Transitioning from female to male is associated with a predicted increase of 10.4 units. And now we're going to rewrite it again And here it is. This is our final version. Compared to females, males are predicted to have 10.24 units higher blood pressure. On average, controlling for all other independent variables in our sample. I didn't rewrite all of that. That's what this ... means here. So this is the final answer. But the reason I went through slowly two initial versions of it is because maybe it'll be a couple of years from now and you might forget how to interpret the result in a regression equation or a regression table of a dummy variable coefficient estimate, like this one. You can still use the language that we use for a continuous numeric variable for every 1 unit increase. And then you can think to yourself, well, what does that 1 unit increase mean? Okay, it means a transition from 0 to 1. What was 0? 0 was the reference group, it was female. 1 was the variable we're talking about, which in this case is male. Then you can rewrite it. Wait a second, that transition means comparing to females, the reference group. This is what we predict for males. So the final way to think about it is that the estimate for a dummy variable in a regression result is the difference between the category for which the dummy variable is coded as a 1 and the reference group, the one that's left out, which in this case is females. So that's the other key way to remember it, that it's just a difference. The coefficient estimate of a dummy variable tells you about a difference between, in this case, the male and the omitted one, which is female. So males have 10.24 higher blood pressure than females on average in this data. Okay, now let's try to do it for non-binary. So now we're feeling more comfortable, hopefully, with these interpretations. So now we don't need to go through this entire preparation and this progression. We can just do it like the pros do it, which means that we'll just go right to the third version, which is that compared to females, so it's still comparing non-binary people to females, because females is the one that's left out. A comparison between non-binary people and males is not occurring in this version of the regression model. So if you really wanted to study that, I would say the best thing to do is just rerun your regression model and leave either males or non-binary people out as the reference category. But usually we are fine with just running it once. We can get an estimate that the difference between males and non-binary people is approximately 10.24 minus 5.77. But of course, these inferential statistics on the right side of the regression table are not an evaluation of the difference between males and non-binary people in our population of interest. These inferential statistics are only telling us about the comparison between males and females and non-binary people and females, the ones who are left out. All right, so let's go back to our interpretation. That was a bit of a side note. So compared to females, non-binary people in this sample have 5.77 units lower blood pressure on average, controlling for all other independent variables, meaning age, marital status. Yeah, and that's it. Great. So that's how we would interpret the result for non-binary people. And then for good measure, we have one more variable left to interpret, which is marital status. And so for marital status, maybe pause the video and see if you can do this yourself. And then I'll display the answer in a moment. And there is the answer in line 84. In this sample of 16 people, on average, single people are predicted to have blood pressure that's 0.88 units higher than married people, controlling for age and gender. So you'll notice that the structure of the phrasing I used for each of these results, right? So this one, and then this one, and finally line 84, it's a little bit different, right? Like here I mentioned the age and gender. Here I just said all other independent variables. Here I started with saying single people, not the reference category. Previously I said compared to females, females was the reference category. All of these phrasings are completely fine as long as you're getting across the main message that there's a difference between whatever this category is, single, and the reference category, which is married or earlier, a difference between, in this case, males and the reference category, which is females, or non-binary people, and the reference category, which is still females for non-binary people as well. As long as you're getting that message across in your written interpretation and spoken interpretation of the results, it's completely fine to change how exactly you phrase it beyond that. All right, so that's all I can think of to say for today about dummy variables and categorical qualitative data and including them in regression analyses. Thanks for sticking it out to the end of this video, and I will see you again soon.